So what is the second derivative test? It means that so there are two cases. If f prime of a is 0, there are two cases, and f double prime of a is positive. In that case, you think about the smiley face. Okay. This is very handy. Every time you have f double prime positive, you want to draw this smiley face and think about what's going on. At this point where you have f prime of 0, f prime equal to 0, what do you get? You get a relative minimum, don't you, right? Then you have a relative minimum at x equal to a, right? Okay, and then if f double prime is negative, what do you know? Now think about the case when you have a frowning face, right? Where is f prime of a 0 here? Where is f prime 0? At this point, at the highest point, you have the horizontal tangent. Horizontal tangent means that the f prime is 0. So at this point, right at the center, we see that it's a relative maximum, right? So you would have relative maximum at x equal to a. That's called the second derivative test. Now, it's often easier to test the function's sign at just a point, one point. Right? Say if we want to find the sign of a function over all the intervals, we had to go through this complex task of first finding out where it's 0 and then picking test points, and you had to do all that, right? Here, you only need to figure out what's happening at that very point. So this reduces the time a lot, okay? So this seems to be better in practice. However, there's one limitation to this. The limitation is that what happens if f double prime is f double prime of a is 0 or does not exist? What happens then? Then this second derivative test can't give you an answer. Okay, so second derivative test, the test is inconclusive. Now, if you did some blood work and sent your blood work in the lab and some of the result came out as inconclusive, what do? You go for more testing, right? Maybe there's something wrong with you. So when you have inconclusive after doing a test, what are you supposed to do? You have to do another test, and the only other test that we know of is the first derivative test, right? So the downside of the second derivative test is that if it works, it's awesome. You don't have to do that much work. It just gives you the answer immediately, right? However, if it fails, then you're back to the first derivative test, so you have to do that work anyways. So that's the downfall. Okay? But hopefully, let's just be optimistic, right? So whenever you have this question of relative min or relative max, let's just be optimistic that somehow our second derivative test is going to give you the right answer. And if it didn't, then what happened is what happened. Just move on, do the first derivative test, and you're okay. So let me give you an example for this. Example 1. Let's say f of x equals to negative 3x to the 5th plus 5x to the cubed. Find all relative extrema. Okay. Let's try this. Solution. F prime is what? Negative 15x to the 4th plus 15x squared, which factors as 15x squared of negative x squared plus 1. Okay. Now, to find extrema, you first have to figure out the critical numbers. Critical numbers are where the f prime is 0 or undefined. So we have to say this is equal to 0. When many things multiply to 0, each individual factor should be 0. So we say 15x squared is equal to 0, or negative x squared plus 1 is equal to 0. If you solve this, you get x equal to 0. If you solve this, well, if I move the x squared to the other side, you get 1 equals to x squared. So what do you get for x value? Plus and minus 1. Actually, just 1 and negative 1. Okay? So those are the values where f prime is 0. These are the critical numbers, 0, 1, negative 1. Okay. Now, if we were to use the first derivative test, it goes like this. You have to draw the number line, place this here, 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 and pick test points. Now it's really ugly because there's no integers here, so you're forced to use a decimal to plug into here, and it doesn't look that pretty, right? So instead of the first derivative test, we're not going to be using this, and we're going to go and try the second derivative test, which is a lot easier. So I differentiate this one more time, and now let's think about what happens at f double prime of 0. What do you get? Uh-oh. F double prime of 0 did give you 0, so this is inconclusive. I don't know what's going on. So inconclusive.
That's unfortunate.
So that's unfortunate, but f double prime of 1 is negative 16 plus 30, so it's negative 30. F double prime of negative 1 gives you 16 minus 30, so it's positive 30. Okay, so if it's negative, it's a frowning face. So what do you get? Relative? Maximum. And what do you get? It's a smiley face. Relative. Therefore, you can say that negative 1 comma 3 minus 1. Negative 2 is a relative bin. And 1 comma, if you plug in 1, it's positive 2. It's a relative max. And for 0, you have to fall back and do the first derivative test anyway. So if I plug in 0.5 before and negative 0.5 and 0.5 afterwards, this is always positives, and this is always actually 0.5 squared is 0.25. So 1 minus 0.25 is 0.75. So you can see that they're both positive here. So the first derivative test actually tells you that it's neither relative nor relative max. So that's the answer. So we were kind of being very optimistic here, but it ended up being one of those cases where we had to fold that the first derivative test.